Hi mathematicians, this is Mr. Almeida. In today's video, we are going to talk about how to write and solve equations of both forms. We're going to solve equations, so let's get into it. First, we want to figure out what is an equation. And an equation is a statement that two expressions, and expressions are numbers, that they have the same value or the same number. So an equation shows that two expressions, like this expression right here and this expression right here, they have the same value. How are these two numbers related? They are the same number. So that's what an equation is, okay? It is a statement that shows how two expressions are equal to each other. And remember, an expression is a number that we get, okay? So we have that. So this is an expression, but if I say that this expression is the same number, is equal to this number, then this entire thing that I've written right here, px plus q, is an equation. To solve an equation, we are going to find a value for the number that is not given to us. So most of the time you're going to see an x, like in this case right here. To solve an equation in x is to find all numbers x, if any, that make the equation true. And any number for x that makes the equation true is called a solution, okay? Any number that makes an equation true is called a solution. So I'm starting with this equation right here, and my goal is to find out what number is x equal to, so that this expression, 20 plus x, and this expression, 50, both equal the same number, okay? So I'm going to go through a process so that I just find out what x is. Now, because these two expressions are equal to each other, we're going to assume that we know what this number x is. That means that we can apply all that we do to specific numbers to this number x as well, okay? So right now I have 20 plus x, and this expression does not have just x. It has a 20 being added to it. So if I want to figure out what just x is, I'm going to subtract a 20 from this number right here. But because I know that both of these numbers are equal to each other, I am going to, whatever operation I do to this number, I have to do to this number because they are the same number. So I have x plus 20. If I just want to have the number x, I can subtract a 20 from this number. So I'm going to do that. I'm going to subtract 20 from this number, okay? If I subtract 20 from this number, I also subtract 20 from this number. So this is what I write. I copy the number 20 plus x, which I'll write as x plus 20, because I can do that with addition. And then I'll copy x plus 20. I'll copy this number right here, which is 50. Now, as I said before, I'm going to subtract 20 from both of these numbers. And 20 minus 20 is 0. X plus 0 is x, okay? And now, as I subtract 20 from this number, I'm going to subtract 20 from this number. So then I have 50 minus 20, which is 30. And then I have x is equal to 30. Now, you think that I was done, but I'm not. If there is a value that makes this true, it's going to be 30. But I have to see, does it indeed make the statement true? Are both of these expressions equal the same number when x is equal to 30? Well, let me show that. My first expression is 20 plus x. My other expression is 50. I know that x is equal to 30 if it is a solution. So I'm going to substitute x with the number 30 because I'm told x equals 30. So I have 20 plus 30. And there is no x in this expression. So 20 plus 30 is equal to 50. And do both of these expressions equal the same number? 50 is the same number as 50. Yes. Therefore, what value did I substitute into the equation to make the statement true? I substituted 30. So I have then proven that x does indeed equal 30 because when I use that number, it makes both of the expressions equal to the same number. So x equals 30 is my solution. X is 30. And I have solved the equation because I found all the numbers that make this equation true. Does that make sense? Okay, so now we move on to the next one. Here we have 3/4 x equals 7/5. I am trying to figure out what the number x is equal to. I then am going to have to figure out a number for x that makes this true. The number x I'm going to figure out by figuring out what am I doing to this number first. Well, I am multiplying it by 3/4. So if I don't want this to be 3/4 of x and I want just 1x, I'm going to have to divide by 3/4, which is the same as multiplying by the reciprocal of the number, which is 4/3. So I am going to multiply both numbers by 4/3, or divide by 3/4, which is multiplied by 4/3. Okay, so I'm going to copy this number right here. But because I want to apply my properties of operations, I'm going to rewrite 3/4 times x as x times 3/4. I can only do that when I'm multiplying numbers. So I have x times 3/4 over here. And then I'm going to copy 7/5 right here. Okay? So now I'm going to apply what I know about operations, in that if I multiply 3/4 by 4/3, which is its reciprocal, I can use the product formula, and I get 3 times 4 all over 4 times 3. I know that when I multiply a number by its reciprocal, this all equals the number 1. So x times 1 is equal to x, so this number is x. And then I use the product formula over here, 7/5 times 4/3. I get 28/15. So then this number is 28/15. So I know that x is equal to 28/15. I'm going to keep this as a fraction because I know when I'm multiplying fractions, I don't want to write them as mixed numbers. So I'm going to keep this as a fraction. So if there is a solution, number that makes this true, I'm saying it's going to be 28/15. So I have to check to see if that actually does make it true by using the number x with 28/15. So the first expression is this one right here, 3/4 times x. So I'm going to write that here, 3/4 times x. And the other expression is 7/5. So I'll write that right down here. Now I'm going to see, does x indeed equal 28/15? So I'm going to substitute x with 28/15. And I do that right here. And you can see the work here. When I do that, I end up being able to use the product formula. I can cancel some factors to simplify this so I don't have some really big numbers that I'm multiplying with, and I get 7/5. So this is equal to 7/5. And this expression is equal to 7/5. Do both of these expressions equal the same number? Yes. This is a true statement. Why is it true? Because x is indeed 28/15. So we say that this is the solution to the equation because it made the statement that both these expressions are equal true by x being 28/15. So we have solved the equation because we found all the numbers that make the equation true. Okay? So that's what it means to solve equations. Now I'm going to get into the idea of writing equations. All right? So let's get into this word problem here because we're going to write an equation and then we're going to solve the equation. All right? So Rita sells 6 tickets for the school fundraiser. The total price of the 6 tickets is $84. What is the price of 1 ticket, T? Write and solve an equation to find the price of 1 ticket. So our goal here is to 1, write an equation, and 2, to solve an equation. And that equation is going to be used to find the price of 1 ticket, and I know that 1 ticket is T. So basically, I am finding a value for T that makes the equation true. But to come up with this equation, I have to first think about what it means to use the operations on the number lines. So Rita sells 6 tickets for the school fundraiser. I have some information. I'm going to keep on going. Remember, my goal is to find the price of 1 ticket. So I'm going to show that right here. I'm looking for the price. So this is the number of dollars. The number of dollars for 1 ticket, per ticket. I know that each ticket is going to cost the same amount of money. I know that I have some tickets, and all those tickets are going to add up to a certain number of dollars. What is the question asking me to find? Is it asking me to find the price of 1 ticket, the dollars per ticket? Yes. So that's what I'm trying to find right there. That is what I'm going to call the number T, okay? Trying to find this number right there, T. All right, now let's go to the other information. Rita sells 6 tickets for the school fundraiser. Well, 6 is the number of tickets. These are the number of tickets, so 6 must be right there. There are 6 tickets, okay? I've made sense of that information. Let me move on to the next sentence. The total price is in dollars, of the 6 tickets is $84. So all of these 6 tickets are $84. So now I have here that $84 is in my model. I'm trying to find out what this is right here, the number of tickets, dollars per ticket. Well, what am I going to do to find this number? This is the size of 1 part. This is a missing factor, so I don't know what a factor is, so I'm forced to use division. I have 84 divided by 6 equal parts. This must be 84 divided by 6. Okay? 84 divided by 6. Now, if you look at this number right here, this is telling us the number of dollars per ticket. T is also telling us the number of dollars per ticket. Both of these numbers are the exact same number. If they're naming the same number, they must be equal to each other. So that's my equation. 84, or T equals 84 divided by 6. Okay? So that's my equation. It doesn't tell me a particular way to write it. However, some people might also write another equation that looks like this. but you just have to write 1. Some people might use what they know. They know that there are T dollars per ticket. They know they have 6 tickets. So they know that the total cost of all the tickets is going to be 6 times T. So 6 times T is the number of dollars. Well, 6 times T is a number, and 84 is a number. They're naming the same point. Therefore, they are equal to each other. So some people might write this as the equation. And while these equations look different from each other, they're actually conveying the same information. Division is finding the number that multiplies the second number that you're dividing to equal the first number. Well, that's it right there. 6 times T is equal to 84. While these equations look different, they're actually conveying the same piece of information. Okay? So that's the equation. If you're trying to find a solution to the equation, which of these formats of the equation would you like to use? We're trying to find a value for T, right? Well, do we already have a value for T? Yes. So you'd probably want to use that one to find the solution, but sometimes you might see it written like this. So off to the side, we're going to find a value for T. We see that T is equal to 84/6. So I can simplify that and do 84 divided by 6. And I see that another way to express this is T equals 14. So that's the solution to this equation, T equals 14. And it's only a solution if when I substitute T being 14 back into the original equation, that it makes both expressions equal to the same number. So my first expression is 6T, which is really 6 times T. And my other expression is 84. Well, I know automatically 84 is equal to 84. So the value of that expression is 84. I just want to see if I substitute the value for T being 14, do I actually get 84? 6 times 14, let me do the multiplication. Do both these expressions equal the same number? Yes, they do. So therefore, the value for T that makes this equation true is 14. Therefore, the solution of this equation is indeed 14. So did I write an equation to find the price of one ticket T? Yes. And did I solve the equation? Yes, I did. So that is how you use your knowledge of expressions that are naming the same number to write an equation. Expressions that are naming the same number. They're both talking about the number of dollars per ticket. And both of these numbers or expressions are talking about the same number of dollars. So therefore, you would write them as equations and then find a value for T that makes the equation true. In both of these cases, T does indeed equal 14. I hope that you better understand how to write and solve equations and can use this knowledge when you are doing your work in the future. Take care, mathematicians.